welcome back, ladies and gentlemen. Today we're going to talk about transformations of functions. If you have gone over this before, you know this probably isn't super duper hard, but if you're new to it, it's not super duper hard, so don't worry about it. Okay, so let's just talk about what you're going to learn really quick so you have an idea of what you're looking at going into this. What you want to be able to do today is if I give you an equation and I tell you some transformations, you should be able to write a new equation that reflects those transformations being done to the original function. Likewise, if you have a graph, you want to be able to look at both graphs and describe the transformation that's happening to those graphs, as well as write some new equations from them. Okay? All right, before we start talking about what the transformations actually are first, let's talk about the way you need to be thinking about the structure of equations, because all four of these equations that you're looking at on the screen right now have a lot in common, even though if you graph them, they're not going to look anything alike. For example, this one's going to be a parabola because it's got the squared. It'll look like a little U. This is an absolute value, so it's going to look like a V. Here's a square root, so it's going to start there and look like kind of a turned, it's going to be half of a parabola on its side. And then this is an exponential, so it's going to look like that. So none of them look the same, but because we have similar structure, they all have the exact same two transformations applied to them. So when we are looking at equations in general, what you want to be looking for is where is the x and what is grouped with the x, or what's inside the parentheses with the x. So here you can see the x plus 2, and here you say, but Mr. Barton, there's no parentheses here. So let's talk about maybe not parentheses. Let's talk about what is the dominating math operation that's happening to your x variable. Anything that's grouped inside that math operation is going to be a similar transformation. So what I mean here is, even though this x plus 2 is being squared, it's inside the squared function. The x and the plus 2 are grouped together. Same thing here. Even though this isn't a squared, it's just an absolute value, you can still see that the x plus 2 is inside this absolute value operation. So you want to think about these things as being grouped together, and this is telling us one of the transformations that's going to happen. Same thing here. Even though it's not in parentheses per se, the x plus 2 is inside this square root math operation. So same transformation is going to apply because of that plus 2. Same thing here. The x isn't even the really key feature of this whole function. It's just in the exponent. But you want to think about the 2 being up in the exponent with the x. The x plus 2 is kind of grouped together. Next, you can see these minus 1s are all outside whatever the math operation is that's going to give these graphs their shape. It's outside the squared, it's outside the absolute value, it's outside the radical, and it's outside the exponent. So these minus 1s are all doing the same thing to these 4 different functions, and they're going to do the same transformation. So even though we have 4 completely different math operations and different graphs and different functions, because of the structure where the x plus 2's are grouped together inside and then the minus 1 is outside in all of these, we're going to have the exact same 2 transformations just because of the structure of the equations and the way things are grouped together. Okay, so let's go talk about how things are grouped a little more and what they're going to do. Okay, so here, this is as general as I can write a function, I think. In general, we're going to have an x inside some math operation. Here I have parentheses with a little number, so this could be an exponent. We could have the x minus h inside a square root. We could have the x minus h in an exponent. It doesn't really matter. You're going to have the x minus h inside some sort of math operation. And then this is going to be responsible for one transformation. Outside that math operation, we will usually have something either added or subtracted to it. We might have a coefficient, so we might be multiplying the main math operation by a coefficient. And we could throw some positives and negatives in there. So these different A, H, and K are all going to do a different math operation. So let's go through those. All right. The K is the most straightforward one to understand. This one is going to be your vertical shift. And what I mean by vertical shift is this is going to move the graph up and down. So if you had like a +2 here, that would move your graph up 2. If you had a -6 here, it would go down 6. So this K is responsible for shifting our graph vertically, so it could go up or down. And the up and down is just determined by the sign. The direction should match the sign. H is the kind of companion of K. K does vertical shifts. H does horizontal shifts. And I need to warn you about H because it's a little funky. You're going to notice that this is minus H. This minus here is part of the equation. And what it does is it reverses the transformation from the sign. So what that means is if I had something like x plus 2, that means move 2 in the negative direction. Negative, there we go, spelling, direction. So you're, spelling, okay. So H is reversed. If it says plus, we go in the negative direction. If it says minus, we're going to go in the positive direction. Some people say things like H is a liar or you can't believe H, things like that, just to let you know that it's going to be reversed. So keep in mind that whatever this sign is, we need to reverse it to get the H value. That'll give us the horizontal shift. Okay. This A in front here, this is in charge of stretching our graph. Stretch, whoops, hold on, I can't spell. Stretching the graph, vertically specifically. Okay, so what that's going to do is if you had a graph like this, you got your parabola and it's sitting on your XY axis, right? What this A value will do is it will take your graph. Let me see if I can grab it here with the smart board. Whoops. This thing doesn't want to cooperate with me. If I were in person, this would be a lot easier, but c'est la vie. Anyway, all right, let me just draw it. So if we had this original graph, and let's say we put a 2 here, what that would do is it would take the entire graph, it won't move it, but it's going to stretch it vertically. Like it's going to grab the bottom, grab the top, and then pull up, stretching it out. If it were down, it would hold down. It'll just stretch the whole thing out, make it a little taller and skinnier. Okay. Then the last thing that we need to talk about for this class is the plus or minus in front of your A value. This plus and minus is responsible for reflecting the graph. And I usually say reflecting the graph vertically. I've seen a lot of different ways to say this in words. Some people say reflect over the x-axis. Some people say reflect vertically. Some people say some other stuff. But I typically say reflect vertically just because I don't like reflect over the x-axis. If we look at this graph and I have my parabola, what this minus sign would do is it would take this parabola and without moving the vertex, it would just flip the whole thing upside down. The reason I don't like saying reflect over the x-axis is because if you have something like this, reflecting over the x-axis to me kind of means that it would look like that. And it has this big gap here where it went from being way up top to skipping that thing, skipping the same amount of distance again, and then flipping it over. That's not what you're doing. You're taking the original and just flipping it on its vertex. Okay. There are ways to do some other transformations, but these are the main ones that we're going to worry about in this class. All right. Let's go look at some examples so that we can get a real visceral understanding. We'll chew on it, let it soak in a little bit, figure out what's going on. So here, what we want to do is describe the transformation. So we're going to write some words that moves f of x to g of x. And I've got two examples for us. All right. So here's our original f of x function. We want to know what happened when we got this g of x function. How do these two things look different? You could go graph these, and that would make it really easy for you to look at the differences. But because we know these patterns with the a, h, k, and the plus or minus at the front, we don't need to look at them. We can just write down the transformations. So the main difference I see right away is that negative in front. We didn't start with a negative. So because this leading coefficient sign has changed, what that's going to do is reflect our graph vertically. Reflect vertically. Okay. The next difference I see is this x squared now has a plus 2 inside. So we had some parentheses there. It's like plus 0. There wasn't anything inside the squared with the x. Now we have this plus 2. So this is our h value. But remember, whatever the sign says, we do the opposite because this negative sign is part of the equation. So whatever we see, it's reversed. So typically, plus 2 in the x direction would mean right 2. So we reverse that and we say this would go left, whoops, if I could draw an L, or not an L, an F, left 2. Okay. And then these plus 3's match. So even though both of these grabs are going to be 3 up from the parent function of just x squared, they're not different from each other. So we're not going to write any transformations because f hasn't changed from g. Both of them have a height of 3. Okay. Now let's look at one that's a little bit more complicated, and we'll just make sure we work through this together. Okay. So we don't have the leading coefficient being negative or changing signs, so we're not going to flip our graph. Both of them are going to be v's that are going straight up because they have the same sign leading coefficient. So we don't need to worry about that. What this plus 1 is telling us is that f of x is left 1 from the origin. And this minus 1 in g of x is telling us it's right 1 from the origin. So if we have our original is left 1 of the origin, it's a negative 1, and our new one is right 1, we want to say what the transformation that moves from the original to the new one is. So instead of saying right 1, we have gone 1, 2 to the right. So we just need to make sure that we're saying how far we're going from the original function, not from the origin. So to get from f to g, we need to move to the right 2. And then this plus 1 for f is going to have it be up 1 on the y-axis. It's going to be there. And then this minus 8 for g means it would be down 8. So we've gone down 1 and then 8 more for a total of down 9. So we need to be looking at the difference between the functions, not just the values themselves. Okay. Last thing we want to look at is an example with some graphs. So we're going to describe the functions, or the transformations rather, that got us from this red graph to this blue graph. And then we're going to try and write the equation for this blue graph using what we know about transformations and this pattern about the general format of functions. Okay. So here's the original function that I gave you for the red graph. Let's go ahead and count to figure out how far we've moved for our blue graph. So this red graph is at 1, 1 for its vertex. To get to this blue vertex, we need to go 1, 2, 3, 4 to the left. And then it has to go down 1, 2, 3. We don't see any stretching or shrinking. This blue graph is just taller because of the way I've cropped the picture of the graphs. Think back to our last notes that you took on Friday, where we talked about just because you see a picture of your family and you can't see their legs in the picture, it doesn't mean they don't have legs, all right? Just because you can't see how long this red graph is doesn't mean it's not there. It's there, it's just cropped, so it's not stretched. So these are our only two transformations. We've moved our red graph left 3, or excuse me, left 4, and then down 3. So what we need to do to get our new equation for this blue graph is we need to apply these two transformations to this original equation. So I'm going to copy the original over here just so I have a little more room to write. So x minus 1 squared plus 1. So if I want to go left 4, left is determined by our h value, which is this number inside the operation with the x. And remember, it's backwards. So if we want to go left, left is typically negative, so we're going to do plus 4 to get that plus 4 for our h. So we're going to add 4 in the h position. Then we want our graph to go down 3. Remember, up and down is our k value, which is this number being added or subtracted at the end. So if we want to go down 3, down is negative, and k just does whatever it says on the box, so we don't need to worry about changing signs. So we're going to do minus 3 in the k position. Okay. Don't worry about order of operation here where you're saying, oh, wait, do I need to square this thing first before I add 4? No, we are just changing the h value to do a transformation. We're not really simplifying this, okay? So if we add 4 here, we're going to have y equals, let me erase that, sorry, a little typo there. Don't worry about the x. Negative 1 plus 4 is positive 3. And then keep your squared. We're not trying to change the shape. We're not changing it from a parabola or anything. And then here, positive 1 minus 3 is negative 2. So this would be the equation of our second graph, the blue one, or we could call it g of x maybe. So when you want to look for transformation on the graph, look for the vertices, count how far you have to move to get to your new vertex. Be aware of if you have to flip it. If you did, you would just throw a negative in front there. And then once you have your transformations, apply those transformations to the value that is responsible for doing that transformation in the equation. All right, I went through that a little quick. So if you need help, go ahead and let me know. You can email me, you can hop in WebEx and ask me some questions, whatever you need. Good luck.